In April 2025, China added 7 elements to its export control list. Within weeks, shipments of rare earth magnets to the United States and its allies fell by 74%. The F-35 fighter, Virginia-class submarines, Tomahawk missiles, Predator drones, all of them depend on those magnets. And there is almost nowhere else in the world that can make them. Rare earths are not actually rare. The 17 elements that carry the label neodymium, dysprosium, terbium, and the others exist in deposits on every continent. The problem is not geology. It is chemistry, separating rare earths from ore, then refining them into the oxides and metals that industry actually uses is an extremely messy process. It generates toxic and mildly radioactive waste, requires enormous quantities of acid, and demands specialized expertise built up over decades. Most countries looked at that process and decided it was not worth doing on their soil. China decided it was. Starting in the 1980s and accelerating through the 1990s, China systematically built the infrastructure to dominate every step of the rare earth supply chain. First mining, then refining, then the production of the high-performance permanent magnets made from neodymium iron boron, the magnets that go into EV motors, wind turbine generators, and military guidance systems. For context, the United States was once the world's leading rare earth producer. The Mountain Pass mine in California dominated global output through the 1980s. But cheap Chinese production undercut American costs, and environmental regulations made domestic processing increasingly expensive. Mountain Pass shuttered in 2002. By the time it reopened in 2017, 15 years of Chinese investment had made the gap essentially unbridgeable. And reopening a mine is the easy part. The processing infrastructure to turn that ore into finished metal never came back. By the time the rest of the world noticed what had happened, the dependency was structural. Here is how complete that dominance is. According to the U.S. Survey Mineral Commodity Summaries for 2025, China produced 270,000 metric tons of rare earth oxide equivalent in 2024, approximately 69% of global mine output. But mining is only the beginning. China refines approximately 90% of all rare earths processed anywhere on Earth, according to IEA data. For heavy rare earths, dysprosium and terbium in particular, the elements that make permanent magnets function at high temperatures, China controls close to 99% of global refining capacity. And for the finished magnets, China manufactures roughly 94% of the rare earth permanent magnets used worldwide. The demand picture makes this more alarming by the year. A single megawatt of direct drive wind turbine capacity requires roughly 500 kilograms of permanent magnets. A typical electric vehicle uses 2 to 5 kilograms of rare earth magnets in its drive motor. Global demand for magnetic rare earths is projected to triple between 2022 and 2035 from 59 kilotons to 176 kilotons annually, according to IEA projections. Every EV rolled out, every wind turbine installed, every defense system upgraded feeds that demand. And almost all of it flows through Chinese refineries. The export controls that Beijing activated in April 2025 were not the first move in this game. China had been escalating methodically. Gallium and germanium in July 2023, graphite in October 2023, antimony in August 2024, tungsten in February 2025. Each restriction probed the response. The April 2025 package, targeting samarium, gadolinium, terbium, dysprosium, lutetium, scandium, and yttrium, was different in scale. These are not niche inputs. Terbium and dysprosium are irreplaceable in the high-temperature permanent magnets that go into F-35's submarine systems and precision-guided munitions. There is no near-term substitute. The impact was not theoretical. Yttrium exports to the United States dropped from over 333 metric tons in the 8 months before the April 2025 restrictions to just 17 metric tons in the 8 months after, a 95% collapse in a single year. Aerospace manufacturers began reporting shortages of yttria, stabilized zirconia, the ceramic coating that protects turbine blades from temperatures that would otherwise melt the metal. Every advanced jet engine, the F-135 that powers the F-35, the engines on the B-52's replacement, depends on that coating. Yttrium oxide price in Europe jumped by over 4,000% in 2025. Each F-35 contains more than 400 kilograms of rare earth material spread across its engines, radar, power systems, and electronic warfare components. The Chatham House assessment in April 2025 was blunt. China's rare earth restrictions threaten Washington's military primacy. CSS put it similarly, the controls targeted the Pentagon as much as any commercial supply chain. By May 2025, Chinese exports of certain rare earth magnet products had dropped 74% year-on-year. Defense contractors began calling the Department of Defense. Automakers began calling their governments. The leverage was real and immediate. China paused some of those controls in late 2025, but retained the licensing apparatus. Starting December 2025, companies with any affiliation to foreign militaries became largely ineligible for export licenses. The tap could be turned off again at any moment. The pause was a demonstration of power, not a surrender of it. The question the West keeps failing to answer is why it allowed this to happen. And the harder truth is that the answer involves choices that seemed rational at the time, letting China bear the environmental burden, trusting that markets would provide, assuming geopolitical risk was manageable. The Pentagon has invested $400 million in MP materials in 2025, with a 10-year commitment to purchase 7,000 metric tons of magnets per year. MP's first magnet manufacturing facility in Texas was expected to begin output by late 2025. A heavy rare earth refinery at Mountain Pass was targeting mid-2026 for commissioning, which would be America's first significant domestic heavy rare earth processing in over 2 decades. But the math is brutal. A refinery takes 5 to 10 years from groundbreaking to full output. A magnet plant requires a skilled workforce that does not yet exist outside China at scale. China built its capability over 40 years of deliberate industrial policy. The West is attempting to compress that into 5 years under supply pressure, with no guarantee that processing expertise transfers on a timeline that matches military procurement cycles. Rare earths are not a resource like oil, where price shocks eventually bring new supply online. They are a capability built through decades of industrial policy, technical expertise, carried in tolerance for environmental cost. China built it. Everyone else did not. And now every clean energy transition and every weapons system upgrade runs through the same narrow gate. The leverage is not theoretical. It showed up in the shipping data in May 2025. The question is not whether China will use it again. It is whether the rest of the world will be ready when it does.